This is our GNSS group project for improving handheld GPS data collection via X method. The authors are Kyson Wolverton, Carson Green, Liliana Coronado, Catherine Franklin, and Hilario Lumbreras. Intrinsically safe areas, better known as IS. It is defined as a constructed such that the electrical energy within the apparatus and of interconnecting wiring exposed to the explosive gas atmosphere is restricted to a level below that which can cause ignition by either sparking or heating effects. It is within a span of 3 meters squared. Technologies not deemed as IS safe pose a safely hazard that could put risk to company assets. It uses affordable and readily available technology, and it uses an intersection method called X method. Our overview and hypothesis is to compare consumer-grade handheld GPSs against RTK, to compare consumer-grade against total station, and to stay within the 2-meter accuracy of the total station while staying outside of the 4-meter radius distance.
For our methodology portion of our project, we had to pick an open area at least 100 meters away from large buildings or trees. So on this map right here, we located a good distance away from the administration building. It's a very open area. Seemed like it would be a good spot to do our project. Our points of interest had diameters of 6 centimeters and 10 centimeters. We used a flagpole and 2 light poles. This was all done on April 12th, 2018. Materials we used were a tape measure, a Leica Viva GS15 RTK with the receiver, and a Leica FlexLine multi-station, and a Garmin 78 handheld GPS. There were 6 flags that we used to measure from. 4 were the points, which we used to calculate the midpoints, and the other 2 was a base and reference. There was 5 people included in our experiment. And to set our points, we measured 4 meters away from our object at like angles to calculate midpoint. To get the true values of our points of interest, we used RTK. RTK works by using the phase of the carrier wave to get real-time corrections with the reference station. We did our RTK from 4 coordinates that were 4 meters apart, and we calculated a midpoint to get our true point of interest. The RTK can get up to centimeter level accuracy, and we had it set for state plane coordinate system and meters.
Okay, so now to our second method of surveying, which was the total station. Just like how Kyson and I both were on the RTK unit consistently throughout the experiment, Liliana and Hilario were on the total station. This was to reduce human error. We use the total station because it provides a highly accurate distance measurements to points around our points of interest. It also provides us another calculation for our points, so we compare different technologies and like their accuracy with the X method. Yeah.
In order to test to see if a Garmin 78 consumer level GPS could be used in order to find the position of an oil well, we selected the NAD 87 datum and used WAS in order to increase the accuracy of these points. During the experiment, we went on the same points as the RTK and collected 30 coordinates. And from this, after the experiment, we averaged these points to find the most probable value. And from there, I converted those values using the NGS data conversion tool into state plane coordinates in order to compare these values to the RTK and the total station. With the Garmin, what we were testing was, although we knew it was a precise instrument, whether or not the accuracy was high enough in order to find the value or the coordinate of the oil wells. So this shows a graphical representation of our experiment, showing the layout and the field conditions of the area. And so what we did was we collected our points at 4 different locations around our object of interest using the RTK, the total station, and the Garmin receiver. And during our experiment, we conducted it at 3 different locations, and at each of these locations we ran 3 trials in order to compare the coordinates.
The chart in the slide that can be seen holds the information comparing the RTK easting and northings to the multi-station easting and northings. I would like to make a special note here that there is a NA present in this box because at the time of the experiment, we were unaware of the capabilities of the multi-station having this information. We have the Garmin easting, Garmin northing, RTK Garmin distance minus the RTK distance subtracted from the Garmin distance, multi-station subtracted from the Garmin points, and multi-station subtracted from the RTK distance. The distances are all in meters, and in the highlighted numbers, you can see the points that met our hypothesis. So, as expected, the multi-station versus the RTK was much more accurate, as Carson described earlier as to why it is, and this was done using our 9 different experiments. This pie chart is to simply display our results that met our hypothesis. So of our 9 trials that we had, 3 of them were under 2 meters of accuracy, but most of them were not. This chart shows displays visually more of the information in the chart 2 slides prior. Here we're comparing the different distances. As mentioned before, the multi-station versus the RTK distance. As seen in a yellowish green, the multi-station Garmin distance in orange, and then the RTK versus Garmin distance, which is the one that we wanted to pay most attention to for this experiment, and that is in a steel blue. As we can see, in the experiment 5, we have a huge outlier, and that it is much more inaccurate than trials 4, 6, 7, 8, and 9. And we do have a graph describing why we think this is in the next slide. But as expected, the multi-station is much more accurate, and we can see that with the yellow-green bar being much lower. What is interesting to see is how fairly close or consistent the Garmin distance is inconsistent with itself. And what I mean by this is the relationship between the orange bar and the blue bar always being very close to each other. And so, as mentioned prior, we were unaware of the capabilities of the multi-station. So for the first 3 experiments, we were not able to put it within the same graph as the slide before. So within this slide, we're just simply comparing the RTK minus the Garmin distance. And as with this being our very first station, we became more accurate as we did it. So our first one had a much greater inaccuracy than our third one. And so this explicitly shows the systematic error that was present within this experiment. The graph in this slide simply shows the standard deviation within the 30 points collected for each point within each experiment, and just showing how varied they were. And so in experiment 5, where we had the greatest inaccuracy regarding the distances versus RTK and Garmin, we had the greatest inaccuracy in the Garmin points. So it is safe to say that there is a relationship between the accuracy of the Garmin within itself and then to the RTK unit. In conclusion, we failed to meet our hypothesis. And more often than not, we did not become within 2 meters accuracy of our desired point. In hindsight, and looking back on this, we would use a flag with the known coordinates instead of using a flagpole or using a light post. There was no need to do that, and it only made it slightly more inaccurate because we did not know the true coordinates of it. There was much systematic error present within this experiment, as seen by the fact that we did not know that the multi-station had the northings and eastings on it, which was seen in our results. We would have used several collections or several trials of the handheld GPS, and by this I mean within the experiment we collected 30 points at each corner, whereas we should have done perhaps like 3 layers of that. So 30 points, use that as one set, 30 points, use that as another set, 30 points, use it as another set. That way we can compare the Garmin coordinates to itself. And this would have had more robust results. This would have led to more robust results. We also hypothesized that using even just a simple antenna would have increased the accuracy of the Garmin, which would have made the which we hypothesized would have it reach within 2 meters accuracy. But we would do that if we were to do this experiment again. Our work cited includes Google, Allen Precision, Garmin, Leica Geosystems, and statistical methods for geography a student's grade.